Okay, now let's do a reaction which is called free radical substitution, which is just limited to alkanes. Before we get to this, let's see how a covalent bond can break. A covalent bond can break by two ways. It can break either homolytically, which is called homolytic fission, or it can break heterolytically, which is called heterolytic fission. Fission means breaking of bond. Homolytic means that it breaks by equal amounts. I'll explain what that means with the help of an example. Let's see chlorine. A chlorine molecule comprises of two Cl atoms. Each atom provides its electron to make this bond. Now in homolytic fission, this bond will split equally. That means this bond has two electrons and they will split, not split. It'll split equally such that this one electron goes back to this Cl atom and this one electron goes back to this Cl atom. Chlorine belongs to group 17, so it will now have 7 electrons in its outermost because it gained its electron back. Not really gained, but it got its electron back and the bond broke. So 1, 2, 3, 4, 5, 6 and 7. This Cl also will have 7 electrons. This one electron right here is unpaired, and this unpaired electron now, this won't be called a chlorine atom. These will be called chlorine radicals. Radicals are those species which have an unpaired electron, and because they have an unpaired electron, they are extremely reactive. They can react to literally anything because they want to just complete their outer shell. So when a chlorine molecule breaks, it breaks into two Cl radicals. Okay, now we come to heterolytic fission. In fission, the splitting of the bond is rather unequal. You have these electrons here. Now they will not split equally but rather unequally, such that both the electrons will go to one atom. So this Cl atom right here got its electron back and got one of the other Cl atom's electron. So it has, instead of 7, now it has 8 electrons. It gained an electron and becomes a anion. And it has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. You see all the electrons are paired. Whereas this Cl atom, it lost its electron and it becomes a cation. And now instead of 7, it will have 6 electrons. 1, 2, 3, 4, 5, 6. All these electrons are also paired. And hence these anions and cations cannot be called radicals, because radicals are those species which have unpaired electron. These are rather what? Anions and cations. One more thing, that whenever there is homolytic fission, a molecule undergoes homolytic fission in the presence of UV light and splits into radicals. You just have to remember homolytic fission for free radical substitution, because radical is only possible if you have homolytic fission. In heterolytic fission, there is no radical formation, right?